So as we look at getting ready for test 3, if we consider this kind of a test 3 review, and again, I'm not a big fan of worksheets that are quote unquote review sheets, because and ultimately what it always ends up with is somebody who works, the problems on the sheet and then wants to complain about the test being too hard and that the problems on the test weren't like the review sheet and yada, 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 yada. So then I found if I just don't give it, then you have nothing to compare it to, and then I don't get in trouble. Again, I found this just by doing a Google search on inverse trig worksheet. That's what I typed in. Inverse trig functions worksheet, and that's what came up. And I went like this. Oh, those look good. Print. And there was a bunch of them. All right, I found some other ones that were only like 10 questions, and that wasn't too good. So, but this is kind of what you're going to look at. I mean, there's all kinds of problems on here, and this is kind of what you're going to see. So let's just kind of look at the first set, section 1. All right. What that's basically testing is, do you understand this chart? This is sine, this is cosine. Not a very good cosine. This is 0, pi over 6, pi over 4, pi over 3, pi over 2, right? This is 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. This is 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. So this first set is basically just trying to identify which of these values and which of these angles is what we're dealing with. So for example, if I say, and I'll look at B, if I say cosine, arc cosine square root of 3 over 2, what I'm asking is, what is the angle where the cosine has a value of square root of 3 over 2? Well, the answer is pi over 6. The answer is pi over 6. If I say sine arc sine negative square root of 2 over 2, the first thing to figure out is when is arc sine positive and negative. Arc sine is positive in quadrant 1, as they all are positive in quadrant 1, and it's negative in quadrant 4. So to do arc sine negative square root of 2 over 2, you got to be using the reference angle pi over 4, but you must put that into quadrant 4, which makes that negative pi over 4. Okay. Looking at G, cosine is negative square root of 2 over 2. Where is cosine negative at? All arc functions are positive in quadrant 1. Arc cosine, cotangent, and secant are all negative in quadrant 2. All arc sine, tangent, and cosecant are negative in quadrant 4. Okay? So when I say when is cosine negative, I'm referring to the quadrant 2 angle. So the reference angle is pi over 4, but if we're going to put pi over 4 into quadrant 2, that becomes 3 pi over 4. Are we straight on that? Okay. Tangent is sine over cosine. So like if you're looking at F, when is sine over cosine square root of 3? Well, that would be at pi over 3 would be the reference angle. Square root of 3 over 2 over 1/2 is square root of 3. If it's negative, that puts me in quadrant 4. That makes it negative pi over 3. Okay. The one thing I'm going to say about, the last thing I'm going to say about as it relates to question number 1 is h. Cosine pi over 2. That's kind of a trick question. And the reason why it's a trick question is this. Arc cosine only starts with negative 1 to 1, yes? And most people don't realize that pi over 2 is actually greater than 1. It's a real Bush League question, to be honest. Because you have to know, because pi over 2 looks like it should be less than 1. Because it's pi divided by 2. But remember that pi is 3.14. So pi divided by 2 is 3.14 divided by 2, which is like 1.57. Does that make sense? 1.57 is outside of the domain for cosine. So that one does not exist. Okay. Now, for number 2, and I want you to understand how number 2 and number and the ones down what the hell just happened? Just got rid of that. All right. These are different than what you see on number 4. Number 4 requires you to do the triangle. All right. These don't require you to use the triangle because all of these numbers, functionally, all of these numbers are coming off the chart. Now you look at E and F, that should be an F. Those don't come off the chart, but all the rest of them do. Okay. So sine negative square root of 3 over 2. When is sine negative square root of 3 over 2? That's pi over 3. Do we agree? Now, what's cosine pi over 3? But you got to know that sine negative square root of 3 over 2 is in quadrant 4. Cosine in quadrant 4 is a positive number. So this answer ultimately will become a positive 1/2. Does that make sense? Positive 1/2. When is tangent equal to the square root of 3 over 3? Well, that's at pi over 6. And then it's got to be negative, so it's got to be in negative pi over 6. So this portion of it is negative pi over 6. And now you're finding the secant of negative pi over 6. As a reminder, secant is 1 over cosine. At pi over 6, cosine is square root of 3 over 2. So 1 over that would be 2 square roots of 3 over 3. We need to deal with whether or not that is a positive number or a negative number. Tangent is negative, puts it in quadrant 4. 1 over cosine in quadrant 4 would be a positive number. Tony, does that make sense? All right. For E, that's negative 1/2. Sine and arc sine are going to undo each other. Which, by the way, they undo each other in that case. They do not undo each other in the case of number 3. Because it's written backwards. Okay. Number 3 is slightly different. All right. Any questions in the first two sections? Yes.
Could you go back over to C on number 2?
Yeah, so you got to find arc tangent square root of 3 over 3. So the question is tangent theta equals square root of 3 over 3. Which one of these produces a tangent that's square root of 3 over 3? Well, that answer is the same thing as when is sine theta over cosine theta equal to square root of 3 over 3. Which, if you think about it, this is simply 1 over the square root of 3. I just rationalized it. Does that make sense? So I need the cosine value to be square root of 3. That's this one. Because if I have 1/2 over square root of 3 over 2, The 2's cancel. Now it'll just be 1 over the square root of 3. That's the one you're interested in. Because it's negative, it puts it in quadrant 4. So in order to find secant of that, secant is 1 over cosine. So it's 1 over the square root of 3 over 2, which is 2 square root of 3 over 3 if you rationalize. Okay. Does that make sense? Do what now? Okay, we're good? All right. Now, the limitations of this system is that it will not allow me to scroll down and move all of that writing up. Does that make sense? So at this point, I'm going to have to get rid of the answers I've already done in order to scroll up and work the next set of series of problems. Does that make sense? Now, with that being said, if you're at home and you're watching this, now's a good time to press pause if you're still trying to write something down. All right? We'll be erasing in 3, 2, 1. Now. And now we scroll.
Sir,
What's up, Doc?
so you say sine and then arc sine will undo each other, but not arc sine and sine?
Right.
Can you give me an example of that?
Yeah, number C.
Can you go through it with me?
C accomplishes the task. All right, so yeah, let's explain why that's not the case. See, when we do, it's very insightful, Gavin, very insightful. Arc sine is only defined in quadrants 1 and quadrants 4. Does that make sense? They're the only two answers you can get. So when you do the sine of those values, you're just going right back to where you were. The reason why it doesn't work is, and this one's just pi over 3. Okay, because sine of pi over 3 is square root of 3 over 2. So sine of what angle is square root of 3 over 2? The answer is pi over 3. Right? But when I do sine 4 pi over 3, sine 4 pi over 3 is sine 4 pi over 3 that's in quadrant 3. Do we agree? So that would be negative square root of 3 over 2. Freaking hell. 2. All right. Now, sine of what angle gives me negative square root of 3 over 2? Well, the genius would go like this. 4 pi over 3, Dryer. Just found it. But remember, arc sine is not defined there. Arc sine is only defined in where? Those two spots. So what you have to do is move the angle from over here, and you need to move that angle to over here. Does that make sense?
Yes, sir.
So that then becomes negative pi over 3.
So it's like a weird reflection, I guess.
Yes. I mean, I don't know if I like the term weird, but yes, it's very much like a weird reflection. Okay? And the weird reflection varies from problem to problem to problem, and that's where it starts really getting confusing. Like, the weird reflection sometimes goes from quadrant 3 to quadrant 4. Sometimes it goes from quadrant 3 to quadrant 1. Like, it is a weird reflection. That is, you got to know what quadrant you're in. Is that positive or negative? And then how does that affect the ultimate arc function that you're dealing with? Is that fair? So when I say to you sine negative 3 pi over 4, well, sine negative 3 pi over 4, that's in quadrant 4, yes? Or excuse me, that's in quadrant 3. But I need, if that number is going to be negative, I need to put that back into quadrant 4 again, which hence is the answer of negative pi over 4. Okay. Now, what is tangent 2 pi over 3? Well, tangent 2 pi over 3, isn't that here? Is that a positive or negative? Is tangent positive or negative here?
Doesn't exist in that quadrant.
Great thought. Arctangent doesn't exist in that quadrant. But tangent does exist, and we're asking for tangent right now. So tangent does exist in quadrant 2, and it is a negative number. Do we agree? So where does the answer need to appear for arctangent? Quadrant 4. Hence the answer of negative pi over 3. You see, if this is 2 pi over 3, the reference angle is pi over 3. Does that make sense? So it's a lot of, what do we have? Is it positive or negative? Where is the arc function defined if it's positive? Where is the arc function defined if it's negative? What's the reference angle? Does that make sense? I mean, there's a lot to process there. All right? And I know one thing. It sounds easy as hell as long as I'm talking about it. All right? Cosine negative pi over 3. Cosine negative pi over 3. What quadrant is that? Quadrant 4, right? Now, is cosine positive or negative in quadrant 4?
Cosine's positive.
Yeah, see, that's the information that we have to be able to get. Okay? Cosine is positive in quadrant 4. So where is arc cosine positive at? Quadrant 1, which puts this angle into quadrant 1. All right. Paris, you okay? Are you sure? Are you understanding today better than you did last time? Okay, well, I'm glad we postponed the test then. People at home right now are going like this, well, you didn't postpone ours. You know what? Different semesters. That's for the people who are watching in the future. The date is October 5th, 1975. All right. Sine negative 7 pi over 6. What quadrant is that? Sine negative 7 pi over 6. Which quadrant is that? It is the second quadrant. Just keep throwing numbers out there, dude. 7 pi over 6. That is 1 and 1/6 pi, right? Going this way, it'd be quadrant 3. But it's negative 7 pi over 6, so it's going upside down, which takes you to quadrant 2. Is sine positive or negative in quadrant 2? It's positive. So where is arc sine positive at? Quadrant 1. So it is pi over 6. Now, I told you could omit M and N because those problems, like, kind of piss me off. Right? Like, I don't know who created the worksheet. And by the way, appreciate it because I totally stole it. But, so if you're watching, thank you. But 2 radians, most people don't know what 2 radians is. Where's 2 radians at? Quadrant 1, 2, 3, or 4? No. No.
We don't know, so why do you keep saying no?
Well, because I want you to think about it. This is 0, this is pi, yes? How many radians is this? 3.14. Right?
That's critical thinking skills we don't have.
So where is 2 at? Quadrant 2.
Somewhere over there.
Is sine positive or negative?
Positive.
So now you got to get that bitch over here. right? Well, what number is that? And the answer is you don't know. It's 1.14.
Subtraction.
Yeah, you subtract it. Omit that nonsense. All right, you can omit this one too, by the way. Where's 4 radians? It's in the third quadrant. All right. So anyway, that's kind of it. Really is kind of. I don't know. I don't like it too much. All right. Any questions on that?
I have a question about J.
J of which section?
3.
Well, negative 5 pi over 4 is in quadrant 2, yes?
Yeah.
Tangent is positive in quadrant 2, yes?
I thought it was negative.
No, it's negative in quadrant 2, so it should be negative pi over 4.
That's what I was saying. You wrote it wrong.
What did I write?
You put pi over 4.
No, you didn't see the negative sign. It's right here.
Totally. I also have a question about D.
Same section?
Yes.
What the hell did I put pi over? Oh, wait.
I was wondering.
Hold on.
I'm so confused.
All right. Sine 5 pi over 6. That is 1/2. Do we agree?
What?
Sine 5 pi over 6 is 1/2, yes?
Yes.
Oh, yeah.
So cosine of what angle gives me 1/2?
No,
Pi over 3.
Pi over 3. Okay. I didn't see where you drew that from.
No, that's a good question because after I missed the first one, I got a little bit scared there. Although I'm going to say I didn't miss it, I just forgot to put the negative. That's what students tell me.
But you consider it wrong on the
You
test.
still give them credit?
No, absolutely not.
Same, no credit.
But I legitimately just forgot to put it. All right. Any questions on that? Please. And again, those kind of mistakes, that's what I was trying to tell you. I mean, I rushed through it pretty quickly. I may have missed a negative sign or a positive sign here or there. I mean, when I was a student, I missed it more than once. Okay? Good news is some things never change. All right. Questions on any of that? Again, if you're watching at home and you'd like to save this, press pause now. 3, 2, 1. You know what? You can get rid of this too. You know what? No, don't want to get rid of that. What's that?
Yeah, that's kind of like you erase half of it. That small one.
All right, so now we got cosine, arc sine, negative 3/5. Okay, so how does this work? Arc sine, negative 3/5. That's quadrant what? If arc sine is negative 3/5, that's quadrant 4, yes? Quadrant 4.
It just takes me a while to think it through. Because I answer too quickly and I say the wrong thing.
It's like when
But
you're,
I got it. I just need time.
it's
So-
like when you're learning to read and you have to like sound out the words like just like that, but with math. You gotta like.
That's a great analogy. For those of you watching at home, I just spared you that. All right. That was a good analogy, though, for real. Arc sine 3/5. What does that mean? Opposite over hypotenuse. This is theta. That is sine theta equals 3/5. Now, some of you are going like this. No, I'll draw it's negative 3. That's just the quadrant. As long as you're dealing with the quadrant and asking whether it's positive or negative and which quadrant that's going to be, you're totally cool. If this is 3 and this is 5, I hope I don't have to do a lot of work to tell you that's 4. It's a 3, 4, 5 right triangle. All right? Some of you are going like this, but what if it's not? Well, then use Pythagorean Theorem. Okay? Now, what is cosine of that? So cosine theta becomes what? Adjacent over hypotenuse. Okay. Tangent is -4. What quadrant is that? If tangent's -4, what quadrant are we in? We are in quadrant 4. If tangent's -4, we are in quadrant 4. Secant in quadrant 4, is that positive or negative? That is positive, yes? Secant is 1 over cosine. That is positive. Tangent is opposite over adjacent, yes? Makes this side square root of 17. Does everybody buy that? That's using Pythagorean Theorem. We'll call this theta. So what is secant? Remember SOHCAHTOA, right? If cosine is adjacent over hypotenuse, secant then becomes hypotenuse over adjacent. So you would get the square root of 17 over square root of 17 over 1. My bad. I'm glad I worked that out. All right. I wrote square root of 17 over 4. Please erase the 4. Sine 1/5. Damn, probably screwed this one up too. You know what the worst part about teaching is? If I say something and I'm wrong, everybody remembers that crap. When I'm right, no one can remember it. But the minute I'm wrong, I'll see that shit on the test. Well, you said, it's on video. Great irony. Sine 1/5 is opposite over hypotenuse, which makes this square root of 24. Do we agree? Tangent is opposite over adjacent. So this is 1 over the square root of 24. This is 1 over the square root of 24, which is the square root of 24 over 24. For those of you that are so inclined, square root of 24 is 2 square roots of 6, and that would be square root of 6 over 12. Okay.
If we don't simplify to that extent on the test, will we still get marked?
I'll probably give you credit. I mean, I'll be happy as hell that you got to that point. This isn't really a class on reducing radical expressions like that. All right. Any questions on that set? All right. I'm going to erase all of that. Go big or go home. Got rid of all of it. All right. Domain and range, I'm going to leave for you to do. I don't have time to deal with that. These are just like the other ones that we just did. So I'm going to leave those for you as well. But these, there's some really interesting things going on here as it relates to question 5. So I want to talk about those, if that's okay. Okay? Because the variables introduce a different level of complexity, and on some level, a level that many of you don't even know exists. So let me explain to you And I'm not trying to be a jerk when I say that. Like, it's not sufficient just to go like this. We'll draw a triangle just like you've been drawing all the other ones. These are a little bit more complicated than that. So here's the reason why. When I ask you for sine 4x over 5, that is 4x is here, 5 is here. Do we agree? Which makes this square root of 25 minus 16x squared. Now, the reason why I said it creates a level of complexity that you don't maybe understand is I have to ask this question. If x is positive, what quadrant are we in? We're in quadrant 1, yes? Well, what if x is negative? We're in quadrant 4. Does everybody understand that? Depending on the value of x, depends on whether or not we're in quadrant 1 or we're in quadrant 4. Does that make sense? Now, secant. Secant is what? 1 over cosine. Does that make sense? Now, secant is positive in quadrant 1, yes? Well, how about quadrant 4? Is it positive or negative? Positive. Do we agree? So when I write this answer's got to be a positive answer. Does that make sense? Let's take a look. All right, so secant, which is 1 over cosine, is hypotenuse over adjacent, yes? So this is 5 over the square root of 25 minus 16x squared. Do we agree? Now, here's the thing. We have to be able to verify that this expression is always positive. Does that make sense? Now, in our case, it doesn't matter because 5 is positive and the square root of 25 minus 16x squared is positive. So positive divided by positive is positive and I ain't got to worry about it. But you have to check it, right? Because if you don't check it, then on the off case that there is a problem, you're never even going to see it. And the only time you're going to see it is when you get it back with the minus sign attached to it. Okay? Let's take a look what I'm talking about. C is a perfect example. C is a perfect example. Let's look at C. We'll leave that. Tangent. Sorry, I always draw the triangle the same way. It makes me feel better about myself. This is theta. This is opposite over adjacent, yes? Makes this 4 minus x squared, do we agree? Or 4 plus x squared, excuse me. Do we agree? Now, if x is positive, 2 over x is positive, yes? Tangent would be in quadrant 1, right? If x is negative, 2 over x is negative, and tangent would be in quadrant 4. Daniel, does that make sense?
Yes, sir.
Now, what is secant? In quadrant 1, secant is what? In quadrant 4, secant is. So the answer that we put here, whatever answer goes into this blank has got to be a positive answer. Does that make sense? Now, what's the answer? The answer is it's the hypotenuse over the adjacent. So the answer is, it is the square root of 4 plus x squared over x. Do we agree? But we just said that it's got to be a positive number, right? Well, but if x is negative, isn't this expression a negative number? And so in that case, we'd use the absolute values. In that case, we'd use the absolute values. Because we want to force that x to be a positive number so that the expression's a positive number.
Are these types of questions can be on the test?
Yes.
How many questions is there a test?
25 or 33.
That's a great number.
25, they're 4 points apiece. 33, they're 3 points apiece, and I give you 1 point for your name.
Thank you for giving us that 1 point.
No problem. Unless you get a 0, then you don't get any points for your name. If you go 0 for 33, then you just get a straight 0. Okay. But this is, I mean, it's hugely important to understand what quadrant you're in when x is positive, what quadrant you're in when x is negative, and how does that affect the outside expression that you're dealing with. Okay. All right. I would never ask you questions like A, B, C, D here. Just know that going back to what we were talking about, arc sine is only defined in quadrants 1 and in quadrant 4 when it's negative. Does that make sense? So is arc sine equal to x? Yeah, if x is between negative pi over 2 and pi over 2. It sure is. But if x is not between negative pi over 2 and pi over 2, that's not x. And we saw some examples up here where we had that problem and it wasn't the 4 pi over 3. Okay? And there are examples of all of those in there. All right? However, arc cosine will always be x. Because it's just asking you for the cosine of the angle that gives you x, and that will always give you back x. Because cosine is defined from quadrants 1 and 2, but cosine itself is defined for all 4. So it's a bigger issue. All right. Then again, domain and range. I'll let you look at those. I'll just give them to you now because we have a few more minutes. Domain is negative 1 to 1 for sine and cosine. Tangent is negative pi over 2 to pi over 2. Notice that those are parentheses, not brackets, because negative pi over 2 to pi over 2 is an asymptote. Cotangent is 0 to pi. That's parenthesis. Arc secant is negative infinity to negative 1, union 1 to infinity, and that's the same thing as arc cosecant. All right, the range, you would get answers from, I'm sorry. I gave you the range for arc tangent and arc cotangent. Negative infinity to infinity for both of these. All right. Then the range would be the negative pi over 2 to pi over 2 and 0 to pi. For arc sine, the range is negative pi over 2 to pi. Those are brackets. For arc cosine, it's 0 to pi, 0 to pi. 0 to pi, those are brackets. And then arc secant, which is 1 over cosine, is 0 to pi, except we're not including pi over 2. Okay, so 0 to pi over 2, union pi over 2 to pi. This one is negative pi over 2 to pi over 2. But we're not including 0. Okay. You could do that by saying negative pi over 2 to 0, union 0 to pi over 2. Brackets on the pi over 2, parentheses on the 0, or the pi over 2 in the middle. All right. We're going to stop here. I'm going to post this on Canvas. It will also be posted to YouTube. Test number 3 comes to a theater near you on Monday, and Donuts and Questions will be on Friday. I will tell you that I do believe Donuts and Questions will be heavily attended, so if you would like a donut, make sure you get here early, because I do feel like they'll be gone early. All right, love you all. Take care.